Hello, my name is John Gabriel and this is the New Calculus channel. Today I'd like to play a little game with you. So what I'd like you to do is to watch this red line down here, okay? This red line down here. And every time I move the line, let me just close the camera. Every time I move the line, and I'm going to move it with this little slide bar here, I want you to count how many times you will see the red line disappear, okay? So watch the red line carefully and count how many times you will see the red line disappear. Are you ready? Okay, let's begin. Well, so I don't know how many times you counted that the red line disappears, and actually it's not really important what happens to the red line so much as what happens when it disappears. Did you notice what happens when the red line disappears? Well, let's have a look. So if we come along here, do you notice anything on the screen there? Well, if you did look very carefully, you'd see that there's this dotted line, right? Which is parallel to the tangent line. Do you see that? It's parallel to the tangent line. And every time the red line disappears, this line is visible. So let's see. So if the red line appears, then that line disappears. Do you see that? Red line appears, that line appears. Red line appears, that line disappears. Red line disappears, and that line appears. So if you look carefully at your screen, you'll see the dotted parallel secant line, okay? So what is the object of this game? Well, if you've read the news, you've obviously heard a lot about something called the gorilla effect. Now, since the time of Newton and Leibniz, and even before them, in fact, since time immemorial, when humans have been around, the gorilla effect has been in place. And what it means is simply this, that you rarely notice anything else except what your mind is focused on, okay? So if the gorilla effect hadn't been part of Newton's and Leibniz's mental makeup, and it didn't exist at their time of life, then they might have noticed that there are innumerably many tangent lines that are actually parallel, and innumerably many secant lines that are actually parallel to the tangent line. Yes? So let's see if we can highlight this line, just to give you an example. If we look at this, we don't want the point F, we want the line, and if we can make that red, there you go. So you see, there are innumerably many parallel secant lines. But neither Newton nor Leibniz nor any of the other mainstream gorillas in the Church of Academia noticed this either. I was the only human in human history to notice this. And someone recently said on the Journeyman Philosopher blog that it's a clever method, but no big deal. Well, you think about it. How is it that if I'm the only human who's noticed this and who's found a rigorous calculus and a way of defining the derivative without any ill-formed concepts, how is that not a big deal? And you will know that many academics who have denigrated my name, who have called me a crackpot and a crank, are very famous individuals in the Church of Academia. I'll talk of people like Gilbert Strang, Professor Gilbert Strang from MIT, Professor Jack Hazenga, Professor David Ulrich. All these absolute morons come out and claimed that my new calculus is unsound. Well, it's turning out that they are all wrong and that I'm correct. And basically what happened really is they experienced something called the gorilla effect. And it's what happens to people who are not capable of lateral thinking or objective thinking and whose minds are only focused on one particular thing. Well, I hope you've enjoyed this presentation and that you'll join me again next time on the New Calculus channel. My name is John Gabriel. Till next time, goodbye.